Hello designers, and welcome to this tutorial. My name is Jax, and today I'm going to be showing you how to create hole patterns just using iLogic and parameters. So let me show you the form, and this is the output of this model. So what we have is we have a normal rectangle plate, and we can apply thickness to it, and we can control hole diameters, and we can control the spacing of the holes. And then we've got indication of the hole spacing. In the next couple of lessons, we will be showing you how to do other types of hole patterns as well. Right, so let me show you how this works. So we can control the length, we can control the width, we can say what the thickness is, we can say what the hole diameter should be, and then the hole spacing. All right, so this just controls the spacing of the holes, and then we can see here what the centers of the hole is. All right, so what I've done is I created a document that you can download. The link is in the description. The document takes you step by step how to create this model. So this is kind of useful if you use this document in conjunction with the video. You should get a good understanding. Right, so we're just going to go and start with step one and follow through until the end. Okay, so let's get started. I'm going to close this model off. We're going to go and create a new model. I'm going to go to metric, and I'm using the standard millimeter IPT. I'm just going to go create. So we're going to create some parameters. You can go to that icon over there that says parameters, or go to manage and parameters. Okay, then you can see your blank parameter window. So we're going to just add 3 parameters for now. I'm just going to go to add numeric parameter. I'm going to call this length underscore x. I'm going to add another one. I'm going to call this width underscore y. And then the last one is thickness. Okay, I'm going to set the length to 100. I'm going to set the width 400. I'm going to set the thickness to 10. Right. Now we can start the sketch. So I'm just going to go start to the sketch. All right, I'm going to choose a 2-point center rectangle. And I'm going to put some basic dimensions in. Right, so I'm going to go and link those parameters to these dimensions. I'm going to go to the parameters. I'm going to select the length, copy that. I'm going to paste it in this dimension. I'm going to go to width, copy that one, and then paste it in this dimension. Okay, so it says fully constrained, that's fine. I'm going to go finish sketch, and then I'm going to extrude this. And I'm going to call this one thickness. Right, so if you do type, just make sure that's not red. So if it's red, it doesn't recognize a parameter. So the spelling and everything should be 100% to your parameter that you set up. Okay. All right, so now we've got a basic model. And this model is fully constrained to our parameters. So that's what we want. We're just going to test this quick. Right, so that all seems fine. Okay, I'm just going to create 3 more parameters. I'm going to go back to the parameters window. I'm going to add another numeric. I'm going to call this offset underscore x. Another one, offset underscore y. And then the last one, hole underscore diameter. Okay, I'm going to set this at 15 for now, that to 15, and this one to 10. All right, then I'm going to put the hole in the plate. So I'm going to start a sketch, and I'm just going to put it on the face of this plate. Right, I'm going to put a point near the corner, and I'm going to give this the 2 basic dimensions, and then I want to link the offset X and offset Y to those 2 dimensions, but I would like the offset X to be in the same orientation as length X, and the same with Y and Y. So just to make sure that we are using the right dimensions or orientation, I'm just going to unhide that sketch. And this one you can see it says length underscore X, so that one should be offset underscore X. Okay, so I'm just going to go and copy offset X and paste it in this dimension, and then offset Y and paste it in that one. Okay, just want to make sure. So this one says with Y and offset Y, so that's fine. I'm going to finish it. I'm going to hide that sketch again. Right, and then I'm going to create the whole feature. So we're going to put the hole there. I'm going to say here this is the hole underscore diameter. Okay, termination should be through all, so that's fine. Okay, it's always a good idea to test your parameter links before you carry on, just to make sure that all the parameters are linked to your model. Just this helps troubleshooting later on if you do have a problem and you don't know where to find it. In most cases it might come from this issue. Right, so it seems like our hole is fully constrained with the parameters. Okay, so that's good. I'm going to add 4 more parameters. If we go to the parameter window, I'm going to add the first one, OA underscore X. So OA stands for overall X. Okay, overall, if you go to the document, you'll see step 3. It's basically the last 2 hole center dimension. So it doesn't matter how many holes you have, it would always be the last 2 holes, right? And then we're going to add a OA underscore Y. We're going to add QTY underscore X, QTY underscore Y. That stands for quantity X and quantity Y. Quantity you don't measure in millimeters, so we're just going to change the unit. So if you just click on the millimeter, I normally just type in here UL, so that stands for unitless, or you can go to the list and select unitless here. Okay, and then also the same with the Y. And then I'm just going to change this to 2 and 2 for now. Right. And then I'm going to create the pattern feature. So that would be the rectangular pattern. If you go to the 3D model tab and you select rectangular, then we have the feature already selected. So we're going to select hole 1, and then we've got a direction 1 and direction 2. Okay, I'm going to expand my origin folder. I'm going to select the direction 1. So direction 1 would be that one. You would notice that the x-axis is at the x-axis over there, and we constrained our model to have the x in that direction and the y in that direction. All right, so we're going to select the x-axis, okay, and the direction is good. It's going the direction we want to. And then we have direction 2. We're going to select the y-axis, but the direction is the opposite way, so we're just going to flip that around. So we do that by ticking flip. Then we're going to say OK just for now. Then we're going to go to the parameters. I'm going to copy the OA underscore X, and I'm going to paste that in the X. Right. And then we're going to paste that also in a Y, and I'm just going to change that to Y. And then we have the quantity, so the quantity would be quantity underscore X, and then the same for Y. All right. And then we have this here, this is selected spacing. We're going to change that to distance. So the difference is instead of each pitch centers, it's going to be the total distance centers rather, right? And then we're just going to go OK. And then we're just going to change the OAX to 70, the OAY to 70 as well. And then you can see this is roughly what we wanted. Okay. We're going to add 3 more parameters. So we're going to go back to the parameters window. I'm going to add a numeric again. In this one we call whole underscore factor. Okay, this is a unitless again. So I'm going to go and type UL. I'm going to set this one to 3. And then another numeric. We're going to call this whole underscore centers underscore X. And then another one just with the Y. Okay. And these we're just going to leave at 1, right? We're going to add our first rule. So we're going to go to the rules tab, right? And we're going to right click on empty space and we're going to just say add rule. We're going to call this length correction. Okay. And then we're going to start an if statement. So I'm going to say here if my length underscore X is smaller than my whole underscore diameter times whole underscore factor, then I want my length underscore X to be equals to whole underscore diameter times whole underscore factor, and end if. Okay, so let's just see what this does. It says here if the length X, right, is smaller than the whole diameter times the whole factor. So let's just see here, if you go to the user parameters, that's the length, which is 100. It says if that is smaller than the whole diameter, that 10 times whole factor, that one there, that's 3, so that's 30. So if the length is smaller than 30, then we want the length to be 30, right? So that just prevents us from making the plate too small. So that would be the minimum length in order to get in the hole in the plate. All right. So I'm going to copy this whole one. Then I'm just going to paste it and then just replace the X direction with the Y direction. So you can highlight the whole word here. Then you can just replace it with the parameter. Right, so now it says width Y, and then we can do the same with length here. Replace that with width. Okay, and that is it for this rule. I'm just going to go save and run. Okay, I'm just going to quickly test this. So if we make this 10, it jumps right back up to 30. That's fine. And the same with the width. We're just getting an error because the pattern doesn't see anybody basically. So we're just going to bring this right back up to 100. 100 there. Okay, so we know that one works. So that's fine. We're going to create another rule. So I'm going to go and add this rule. We're going to call this whole control. Okay, and this is going to be another if. So we're going to say if the length underscore X is smaller or equal to the whole underscore diameter times brackets whole underscore factor times 2. Okay, then we want the quantity underscore X, underscore X there equals 1. I'm just going to say here else the quantity underscore X equals ceiling brackets OA underscore X divided by bracket again, hole underscore diameter times hole underscore factor. And I'm going to say here and if. Okay, so we just want to see what this does. So we're saying if the length, right, that length is smaller or equal to the hole diameter, that 10 over there, times the hole factor times 2, so that would be the 3 times 2, so that would be 6, so that would be 10 times 6, that gives you 60. So if the length is smaller than 60, then we want the quantity of that direction to be 1. Okay. If that is not 60, if it is 61 and up, then we want the quantity to follow this argument. Let me quickly explain what ceiling is. So ceiling is like a round function. So this is a round up. Okay, so if we have a number, 2.385, then the ceiling would take that number and it would bring it to 3. Then we also have a round. A round, we just take it to the nearest whole number. So if that 2.3 would become a 2, and then we have a round down as well, so that would be floor. So floor would also take the number and just bring it down to the nearest whole number. Okay, so we, in our case, want the ceiling. So if our quantity is 2.38, we want our value to go up to 3. So this just helps us not to have a 2.3 quantity or something like that. That can mess up our model. So then what we have is if our length is smaller or equal to 60, then we've got the 1. Or if it's bigger than that, then we want the quantity to be the overall center distances between the last two holes to be divided by the 10 times 3, so that gives us 30. So then we want that overall dimension to be divided by 30, and that would give us the quantity that we need. Okay, so I'm going to add another one here. I'm going to say offset x equals the length underscore x divided by 2. And then here as well in the else, we want the offset underscore x equals hole underscore diameter times the hole underscore factor divided by 2. Okay, so what this means is if our length is less than or equal to 60, then the offset needs to be that length divided by 2. So what it's going to do is going to take the hole and put it right in the center of that plate. Okay, and then if that is 61 and up, then we want that offset to take the hole diameter and then times it with the hole factor, so the 3 divided by 2, so it'd be 1.5. So then our offset needs to be the 10 times 1.5 gives us 15. All right, so our hole diameter here is 10 there. Our factor is 3, so 3 divided by 2 is 1.5. 1.5 times 10 gives you 15. Okay, then I'm going to add the last one. This one would be overall. So overall underscore x equals 1. And then the same here, we're going to say overall underscore x equals the length underscore x minus the offset underscore x times 2. So if we can just look at what this does, we're saying that if the length is 60 and less, we want the overall center distance to be 1. We basically doing that because there's only one hole. There is no center distance between two holes, and we don't want it to display 0 or anything like that. That's going to give us an error on the rectangular pattern. So we're just saying just give it a value. Okay, and then if that length is 61 and up, then we want that that center distance to be the length minus the offset times 2. So that would give us the 100 minus the offset minus the 15 times 2 give us 30. So that would be 100 minus 30 gives us 70. All right, so then this would be 70. Okay. All right, and then these would basically control our pattern. All right, so the only issue we have with this rule is the way it flows. Okay, so in these rules, it always starts at the top, and it reads one line, and then carries on to the next line, and then goes through until the end. Okay, so it doesn't go back and then reread all the rules. So in our case, we would have an issue because we're saying set our quantity based on the overall dimension, but the overall dimension is being controlled after this line here. So this would basically the quantity would be calculated based on the center distances, but the center distances hasn't been set yet. So we wanna control the center distance before we control the quantity. Okay, so we copy the whole line. I'm gonna cut it actually, Control X, and then I'm gonna just paste it here. Okay, so let's just see. So we have our center distance set already. Okay, so that's fine, but it also reads the offset. So the offset also are being controlled after this line. So the offset now is at the last line. So we want to take that one and also put it in front. Okay. Okay, so let's just see what it would do now. So the offset are being set based on hole diameter and hole factor. That's fine because both of them are manual inputs. Okay, so that is perfect. And then we control or set our overall dimension. Okay, so the length is also manual input, and the offset have been set already, so that's fine there. Okay, and then we have the quantity that uses the overall center distance and the hole diameter, which is a manual input, and a hole factor, which is a manual input. So that has been set before, so that is fine. Okay, so now this flow is right here. This one doesn't matter because that's just a value, that's a value, and this is a manual input, so this one wouldn't make any difference. Okay, I'm just going to take this whole rule, I'm just going to copy it down. Okay, and then we want to change this for the Y direction as well. So I'm just going to take this and then change it with Y, and change that to Y. It would be Y, that's Y, this would be width, and that's Y, that one, this one, this one. Okay, so that's all the X's changed to Y, so that's fine. So we just want to quickly test that rule and see if everything works. So we're going to go to the parameters. We're just going to change this to 10. So it brought it up to 30. So that rule works. It also changed the amount or the quantity to 1. Right. So that's fine. I also put that hole in the center of the plate. That's perfect. So I'm just going to make this 50. So the hole remain in the center, that's 100%. And then let's go 70, right? So it changed it to 2 holes, okay? And remember that's 61. So this plate is now more than 61. So it added the 2 holes, and it also took the hole and took it back to the edge, and it used the offset distance, right? So that offset there, that 15, it started using that. So that's 100%. And then go back to 100. So that all looks okay. We just want to quickly run through the Y just to make sure. So that 10 goes to 30. The 70 puts in 2 holes. and then 100, and that is perfect. Okay. We also control the hole diameter, so let's go to 5. Okay, so that all updated, that looks perfect. Okay, and then the hole factor, so let's make that 2. So it basically created more holes based on the smaller hole factor. Okay, so that's nice. I'm gonna go back up. All right, the only thing I would like to add here is the fact that your holes are too small based on the thickness. All right, so I'm just going to add a rule that controls the hole diameter. I'm going to say here, right click, add rule. I'm going to say here, hole diameter control. Okay, I'm going to say here, if the hole underscore diameter is less than the thickness, then I want the hole diameter to be equal to thickness. So I'm just going to copy this, paste, and change that to equals. And then end if. Okay, so if the hole diameter is less than thickness, we want the hole diameter to go back up to the thickness distance. Okay, so there are no x's or y's, so that should work for both directions. Okay, and then we're going to add another if. So we're saying if the hole underscore diameter is more than the length underscore x divided by 2, then we want the hole underscore diameter to be equals to length divided by 2. I'm sorry, length underscore x divided by 2. And then we're going to go end if. So what we're saying is if the hole gets too big, if it's more than the half of the length, then we want the hole diameter to be equals to half the length. So this just controls the maximum diameter of the hole. Right, so I'm just going to copy this and paste it. I'm just going to change this to y as well. Okay, so if this one or this one is more than half of the plate size, then the hole diameter should update to that maximum size. Then we're going to go save and run, and then we're going to go to the parameters just to quickly test it. Now we have 100 length and we have a hole diameter of 10. So the rule is saying if the hole diameter is bigger than half of the length, so that's 50. So if the hole diameter is more than 50, then something has to happen. So let's just quickly check it. I'm going to change this to 60. Okay, so what it did is it actually brought up the length up to 180. Okay, so let's go back to 100. Okay, it wouldn't let us because our hole diameter is too big. All right, so if we go to 40, we can bring this down to 100, and it brings it back up to 120. All right, so you see how this works. Go 30, 100. Okay, I would like to add another rule. This rule gives us a display of the hole centers. Right, so if we go and add the rule, we're going to call it hole center display. And then we're going to say here, if the quantity underscore x equals to 1, then the hole underscore centers underscore x equals to 0. Else the hole underscore centers underscore x equals round overall underscore x divided by another bracket quantity underscore x minus 1, and that would be comma and 1. Right, so then we end this off. Okay, so let me quickly explain this. So we're saying if the quantity is 1, the whole centers is equals to 0. So we want it to display 0. That's fine. Okay, so this rounding here, we just trail our zeros, we'll make it a whole number. I actually took it to 1 decimal place. So that would be, if it's 25.384, then it would be 25.3, right? So it rounds this equation here. So that's the overall distance divided by the quantity minus 1, right? Okay, then we're going to copy this and make it work for the y. Just like that. I'm going to save and run. Update. Okay, so now that would control these two here. Alright, so we have one hole, so they are displaying 0. That's fine. So we want to basically make this, or the hole diameter, let's change that to 6. So we do have a couple of holes in. So this one says the hole centers in the x direction is 35 millimeter, and the hole centers in the y direction is 37.5. Okay, so remember the round, it gave us 1 decimal point. Okay, so that's perfect. Something I'd like to do, just to make sure that your rules are always running, is to add the rules in your event triggers. I'm going to go to Manage, the iLogic section there. We're going to go to Event Triggers. And then this is the list of your rules. So those rules would be those ones over there. And then all we do is we drag it to a specific event. Okay, so I'm going to take one. I'm going to drag it underneath any model parameter change. So I'm going to put it there. So then we just drag them one by one across, all under any model parameter change. Okay, you're done. So that just ensures that your rules always run. We're going to just create a basic form with just the parameters that we would like to see. The problem with using this window here is you never really know which ones to change always. Right, so we're just going to put the ones that we need in a simple form. Okay, so I'm going to go to Forms tab over there. Right click, and I'm going to say Add Form. And then this is your window of your form. Basically, you're just going to put your parameters in this space over here. So I'm just going to take the length X, I'm going to drag it across. We're using the Y as well. We're using the thickness, not the offsets, but we do use the hole diameter. Okay, not the overall distances, not the quantities, but we do use the hole factors. Okay, and then we also want to see the centers here. Okay, but you'll notice that the centers, you want read only, they are not being controlled, so we just want a display of what they are. So the way you can see if they are is if you go to the bottom section here, you see read only, it says false. Okay, so we want to change that to true. Okay, and also with this one here, change that to true. So it's only a read only. Okay, and then also what we can do is just change the descriptions here. I'm just going to take this one. I'm going to say that is length, that is width, the thickness is fine, hole diameter, okay, hole, let's call this spacing factor, that's fine. Then hole centers across width. Okay, sorry, that is length. And then also for this one. All right, so you can rename your parameters here. It doesn't affect anything on your rules or on your parameters here, because it does keep the inventor name here. All right, so this is fine. We're just going to go OK. I'm going to go to the form here. I'm going to click on that, and then it just displays the form how it is. So you'd notice those two read onlys, you can't change them, so that's fine. And then we can just start playing around with our model here. Okay, just change the sizes there. All right, so it looks like everything is working. Okay. Yes, so everything is perfect. All right, so I hoped all this helped. Like I said in the beginning, I am going to cover more hold patterns in the following lessons. So I sincerely hope this video helped with something that you've been struggling with. Thank you for watching, and I hope to see you in our next tutorial. As always, please visit our website. You can download iLogic 3D models over there, as well as visit the forum where you can ask specific questions and get the answers from the masters.